Good afternoon, students. Welcome back to online maths class. So in the last class we have started with the exercise 6.5 and we have solved the first main question. So in today's class let us continue with the second main question of the exercise 6.5. The question is, find the maximum and minimum values if any of the following functions given by. Here we have 5 cases and we will have to find the maximum and the minimum value if it exists. So we'll take up the first one. So we'll go for the Roman number 1. F of x, which is equals to f of x equal to mod x plus 2 minus 1. Mod x plus 2 minus 1. So the modulus function is always greater than or equal to 0 for any real number. So here we know that mod x plus 2, mod x plus 2 is greater than or equal to 0 for all x belongs to R, for all the real numbers. So mod x plus 2, either it is 0 or greater than or equal to or greater than 0. So now we need minus 1 here. That means both the sides you need to subtract 1. So here overall we get mod x plus 2 minus 1 and then greater than or equal to 0 minus 1. So what we are doing here, we are subtracting 1 both the sides, and then now what is this now? This is nothing but f of x. See here, it is f of x. I can write this as f of x. F of x greater than or equal to 0 minus 1, it is minus 1. So it is minus 1. See here, f of x can have minus 1 and greater than minus 1. So here the minimum value of the function is minus 1. The minimum, it is minus 1, and the maximum can be anything because it is greater than minus 1. That means 0 and all the positive numbers. So here the minimum value of the function is minus 1 and there is no maximum value for this given function. That we have to write now. Therefore minimum value of f which is equals to minus 1, minimum value of f equal to minus 1, and hence there is no maximum value, hence there is no maximum value for the given function, hence there is no maximum value, hence there is no maximum value. So this is the answer for the first one. Then we'll move on to the second case. So note down this, then I'll rub this off. Well, we'll solve the second one now. Roman number 2, g of x which is equals to minus mod x plus 1 plus 3. Again we have to go with the same concept. So mod x plus 1 is greater than or equal to 0 for all the real numbers. We know that mod x plus 1 is greater than or equal to 0 for all the real numbers, for all x belongs to R, R means the real number. Then here we have minus of mod x plus 1, so, but minus of mod x plus 1 will be less than or equal to 0. So this is positive, but here you have the minus sign. That means minus into positive number is always less than 0. It will be negative. So here is less than 0 for all x belongs to R, for all x belongs to R. So what we need now, you need minus mod x plus 1 plus 3. That means, so both the sides you need to add 3. So here this implies minus mod x plus 1 plus 3 plus 3 plus 3 less than or equal to 0 plus 3, less than or equal to 0 plus 3. So what is this now? This is nothing but g of x. So here I can write this as g of x less than or equal to 0 plus 3, it is 3. So here g of x value is either 3 or less than 3. That means the maximum g of x at the max can have 3 and the minimum can be anything less than 3, means it is 2, 1, 0 and all the negative numbers. So there is no limit for the minimum value, but maximum you can have 3. Therefore the maximum value of the function is 3 and there is no minimum value. That I have to write now. Therefore maximum value of g which is equals to 3, the maximum value it is 3 and there is no minimum value for the given function. Hence there is no minimum value. For the function g. So this is the answer for the second case. Note down this and then we'll move on to the Roman number 3. Well, the third one it is h of x equal to sine 2x plus 5. So the third one, h of x which is equals to sine 2x plus 5, sine 2x plus 5. So we all know the range of sine function that we have studied in our first PUC. What is the range of sine function? It is minus 1 to plus 1, that is closed interval minus 1 comma 1. So we know that sine 2x greater than or equal to minus 1, sine 2x greater than or equal to minus 1 and less than or equal to plus 1. This is the range of sine function. Sine 2x greater than or equal to minus 1 and less than or equal to plus 1. So what we need now? We need sine 2x plus 5. That means for every term I will be adding 5. So minus 1 plus 5 less than or equal to sine 2x plus 5 and then less than or equal to 1 plus 5. So simplify this now. 5 minus 1 it is 4, then less than or equal to this we can write it as h of x. It is nothing but the given function. It is h of x and then less than or equal to 1 plus 5 it is 6. So see here h of x can have the value 4 or greater than 4 and h of x can have the value 6 or less than 6. So maximum it is 6, minimum it is 4. Therefore maximum value of h which is equals to 6 and then minimum value of h which is equals to 4. The minimum value it is 4 and the maximum value it is 6. So write down this and then we'll move on to the fourth one. So Roman number 4, it is f of x which is equals to mod sin 4x plus 3, mod sin 4x plus 3, mod sin 4x plus 3, that is plus 3. So now again you have sin 4x. Now we all know that sin 4x is greater than or equal to minus 1 and less than or equal to plus 1, because that is the range of sin function. We know that sin 4x greater than or equal to minus 1, less than or equal to plus 1. So here we need sin 4x plus 3. That means for every term we have to add 3. So minus 1 plus 3 less than or equal to sin 4x plus 3. This is a separate term. 3 is a separate term. So we can write this as like this: sin 4x plus 3, then less than or equal to 1 plus 3. So now 3 minus 1, it is 2. So you get 2 less than or equal to sin 4x plus 3, and then plus 3, and then less than or equal to 1 plus 3, it is 4. So now you need the modulus. So for every term take the modulus. Mod 2, it is 2. Mod 2, it is 2. Then I take the modulus function for this one. Mod sin 4x plus 3 mod complete plus 3 mod complete, then less than or equal to mod 4, it is 4. So what is this now? This is nothing but f of x. So 2 less than or equal to f of x less than or equal to 4, less than or equal to 4. So now here f of x can have 2 or greater than 2, and it can have 4 or less than 4. That means the maximum value it is 4 and the minimum value it is 2. Therefore maximum value equal to 4 and the minimum value it is 2. So this is all about the Roman number 4, and note down this, and then we'll move on to the last one. Well, this is little different. Fifth one. So he has given h of x which is equals to x plus 1, and here x plus 1, and here x belongs to open interval minus 1 comma 1, and x belongs to minus 1 comma 1, x belongs to minus 1 comma 1. So now let us draw the graph for x plus 1. So let us draw the graph. This is x, y, x dash, this is origin, this will be y dash. So now y equal to x is always a straight line passing through the origin, but here you have x plus 1. That means the graph must be shifted 1 unit vertically on the y-axis. So this will be the graph of x plus 1. Approximately you need to draw. So now he has given the interval open interval minus 1 comma 1. This will be plus 1 and 2, 3. So here it is minus 1, then minus 2 and minus 3, and so on, it continues. So he says in between minus 1 and plus 1, open interval means you have to leave the end points, take in between value. So in between these two you have to search for the maximum or the minimum value. So it is very difficult to locate such points. So near to 1, this will be 1, ಆದರೆ ಇದು 1 ಆಗ್ತದೆ ರೀ. ಇಲ್ಲಿ ಓಪನ್ ಇಂಟರ್ವಲ್ ಇರೋದ್ರಿಂದ ಇದನ್ನು ಬಿಡಬೇಕು ನಾವು. ಯು ಹ್ಯಾವ್ ಟು ಲೀವ್ ದಿಸ್ ಆ್ಯಂಡ್ ಸಮ್ವೇರ್ ಹಿಯರ್ ಕ್ಲೋಸ್ ಟು 1 ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ, and so here close to -1 you will be getting the minimum value. It is very difficult to locate such points. That is why this has got no minimum and no maximum value. So here no maximum value, no maximum and minimum value, and minimum value. So this is all about the fifth main. With this we have completed the second main question.